I'm Arpit, your host, and joining me today are Schaun and Paul, two brilliant data scientists and also the AMP co-founders. So today we're talking about getting comfortable with the idea of decision automation, or getting comfortable with machines making decisions on behalf of us humans. So what exactly does that mean, Paul? Schaun, do you want to just chime in?
Yeah, so I think ultimately that's what we're interested in, is making decisions, because you can think about any action that a machine can take ultimately as being prefaced by a decision it had to make to take that action. And when it makes the decision, it's really doing the work. And in fact, every action has a non-action, and that the non-action is part of the decision set, right? It's something you can choose to do. You can choose to not do something. So in marketing, we can make a decision about sending an email. We can also actively decide not to send an email. It says we can decide to offer a discount, or we can decide not to offer a discount, or we can decide, which discount to offer.
To add to that, speaking as a data scientist, decision making has not historically been the province of data science. Data science has been all about understanding. The work that's been done so far has always been like producing some kind of insight or metric or something like that, with the assumption that yes, someone would eventually act on it, but this question of how they would act on it and how they would shape that decision has always been sort of ambiguous. That's kind of where data science stopped in a lot of cases, and increasingly that's changing.
Yeah.
Okay.
In fact, in old school machine learning, data science for business type books, by old school I mean like late 2000s, you'd often have this distinction between machine learning for human versus machine. So is the output going to a human or going to machine? And in most cases, it was actually going to a human. You were generating an insight, you were creating an analysis, you're creating a model that a business team or a CFO or a product manager or somebody would interpret and then make a decision. And then the first sets of machine read like decision were actually recommender systems, which is part of this series. It was sort of where you could just go from the model output to a decision instantiated in a screen that would sort a list of food items, a list of movie items, etc. Another great example of this is the world of investing, where historically most investing was humans, and you can think of the classic case of like the movie Wall Street from the 80s, and you got all these people in the bull pit on Wall Street, and they're all buy, sell, and they're doing that, they're all on the phone, and they're talking back to an analyst who's telling them, now, yes, buy now. And they may be doing that based on some analysis. And then you got like the world of Graham and the value investors who are doing that based on reading all of the detailed reports of earnings reports and all those things. And then through the 90s, you moved more and more with computers and more investors having access. They would like run these complicated models, and then those models would tell them invest at this price point. But the human would still go and actually press the invest button. And then through the 2000s, what you moved more towards was algorithmic trading. So the decisions were the output of a model, but again, still oftentimes it was, and maybe that might connect to some automation system that then would like close the loop. But then increasingly it became high frequency trading, which by definition had to be machine driven. It couldn't have a human in the loop. So you can sort of see that, but I think most businesses in the world today, I think probably most of the folks who would be dialing in or listening in product teams or marketing teams or even data science teams, don't live in that world where most of the decisions they're interested in are so well defined as a trade, where in the market all you can do is buy and sell. Like that's the decision set. So I think what's worth it to do is actually to step back and kind of think through what is actually a decision. And it does seem like a very basic question because we live our lives making decisions, but we can actually kind of do an old school analytical philosophy. We can actually ask, well, what does it mean to make a decision, and be really concrete and precise about it. And I think there's a set of questions that you can ask. And so, for example, I think we can qualify decisions. We can kind of describe them, and then that description can help us decide where we might use something like an agent, where we might use something like a model, where we hand that decision to a machine. And so some of those questions might be, is the decision answer set constrained? So an answer set, again, for algorithmic training, just to keep it super simple, is buy or sell and the price point. A decision set for a recommender system, like let's say the home screen of a food delivery app, is item 1, item 2, item 3, item 4, and what's the rank order of those. And so that actually is n factorial. So it's actually the actual instantiations, but it's constrained because you can only put items in that list and they have to be sorted. Quick example of a non-constrained answer set would be product management. What do we build? It's not. It's like, well, we could build this, we could build that. Let's actually go and fix bugs this sprint, or let's launch a new product, or let's do some research. The output set of that decision is pretty unconstrained. It's unbounded. So that's one, right? Second question we might ask is the decision repeatable? So again, deciding what to show on a screen happens every single time the screen gets loaded.
Yeah.
Again, a hiring decision is being made a few times a year, depending on the size of the company, or it's being made lots of times, but across different teams. So we really want to think about it, because a decision that's not repeatable almost certainly is also not constrained. And in those scenarios, it's not terrain that an agent is accessing. It also changes the way you evaluate the outcome of the decision.
In my experience, a lot of people who are making decisions in business, I think, tend to treat constrained repeatable problems as unconstrained and unrepeatable in practice. Like every time they're going to go message their users about something, it's like it's a whole new thing. And yeah, they'll think about what they were doing before, but they're not systematically thinking about it, which means they aren't actually leveraging all of that experience, except in this very sort of filmy way of just, oh yeah, I'm just going to write what I think is going to work. Maybe I'll talk it out with a few people. But in fact, problems like that, especially communication problems in a business setting, are usually quite constrained. There's a basis for ranking priorities. There is a basis for selecting from a set of things rather than saying just blue sky, what should we talk about? There's a basis for actually even constraining the way you talk about it. And unless you make those things concrete as part of your business process, and preferably in line with our subject of recommender systems, but create tooling that can support that structure, you end up wasting a huge amount of effort. You end up spending a lot of time in this very inefficient process of trying to come up with something from whole cloth when you don't need the whole cloth. You can actually put it together very quickly by pieces.
Yeah.
So
Interesting.
I think what would be interesting to do here is to actually just sort of say, all right, if we take a decision and we break it into basically 3 pieces. There's the decision set, so it's the options of the decision. There's the outcome set, so what happens based on the decision. And then there's the information set, which is what is the information or the material that's relevant to making the decision and to evaluating the output or the outcome. And I think if we dive into those 3 pieces, you can kind of come away with a much better tool set to do things like recognize when you're actually making the same decision over and over again in a way where you've been treating it as if it was like lots of independent decisions. If you can recognize that actually it's one decision just made over and over again, that's a big opportunity to win. And you can kind of like also begin to ask yourself, well, how can we improve the evaluation process? If we're going to give it to agents, what does it mean to evaluate it? So yeah, big 3 pieces for me are the decision set, the outcome set, and the information set.
So what is the answer set then? Is it different from the outcome set?
To me, the decision set is the choice that you're making, and then the outcome. So let's just think about that. So a simple, very simple example would be, think about back in grade school or high school or college, and you have a test. So a test is a series of questions, and each question you're making a decision about how to answer it. And an essay prompt is an unbounded decision set, because you can take all 180,000 words active in the English language and you can string them together in so many possible ways to make that essay. And of course, we have to evaluate it, but you can put it, you can answer it, you can make the decision about how to answer it any number of ways. Whereas a multiple choice question only has 4 answers. So you're making a decision between 4 options, just It's very limited, right? And so sort of similarly, we could transfer it over to marketing. We could say all the things you could say in an email is relatively unconstrained. It's constrained because you're talking about your business, but you could talk about your business in so many different ways. But the item that you put in there, let's say you're an e-commerce app or a running app, the item that you reference, it's constrained because you only have 30 runs in your app or 1,000 SKUs in your store. There's way more ways to write an email in English than 1,000 ways, but there's only 1,000 items that you can recommend a person would buy. And you can really kind of start to think about what are the nature of the constraints of your decision set. Because, for example, streaming content, you can think about that decision as being unconstrained in location. It doesn't matter where in the world somebody is, theoretically, they can watch your content. You can recommend any movie. But if you're a food delivery lab, you're actually location constrained because you can't make the decision to tell somebody in Bangalore about a delicious restaurant in New York. That would be absurd, like that's outside of the decision set. Or it can also be constrained in the sense of whether it's a rivalrous good. In economics, we have the concept of rivalrous. So a movie is non-rivalrous because you and I can both watch it. There's no competition. But in real estate, if you're a real estate business, only one person can buy or rent a house. So if I'm trying to get you to buy it, if I offer it to one person, hoping that they'll buy it, it means I'm not going to be able to offer it to somebody else, hoping that they'll buy it. I can offer it to both and let them compete, but ultimately I'm kind of on their side. I'm trying to help them. And I have to recognize that it's constrained. So these things start to help you think about how you would make that decision and what are the parameters that constrain that decision, so that when you give either a new person on your team who knows nothing about your business and they've just joined, you have to tell them how to make the decision. And very similarly, if you have an agent, an AI, they have to be told how to make the decision. They have to be given guidance on how that decision that they're going to be making is constrained.
I hadn't thought about that distinction between rivalrous and non-rivalrous too much before, but in an interesting way, it seems like e-commerce is a rivalrous condition that often seems non-rivalrous. I mean, it seems like, okay, everyone can buy these shoes, but in fact, you have a limited inventory. And even if it's not like, oh, if I sell these shoes, then I'm out of inventory and can't sell them anymore, that's a pretty clear distinction. But what if you have plenty of shoes, but you have a surplus of yoga wear? Those shoes are a more constrained resource. And as a business, you may not be worrying about like, oh no, what if I offer this, but then I can't offer it to someone else? But rather, if I don't offer some of this yoga wear, I'm incurring other costs in terms of storage, or that department is not going to be making its quota. Inventory is a decision that should be incorporated more often into decision making. And it goes back to what I said before, that when you don't treat this systematically, then it becomes very, very difficult to actually optimize any of those things. I mean, businesses run on inefficiency most of the time.
Right. So can we talk a little bit about decision repeatability and frequency now that we are prepared to sort of assess a set of decisions that we have?
You've got the decision. What we also want to know is, are we making it over and over again? And the reason that matters is because that determines whether it's worth it for us to invest in setting up a systematic way to make a decision. A lot of times in life, we only get the choice to make one decision. So in a sense, why spend tons and tons of time? That's called analysis paralysis, right? Where you spend so much time and the importance of the decision doesn't warrant that investment. But the other reason why it matters is because if you only have one chance to make the decision, or a very infrequent chance to make the decision, then you can't really learn, because learning by definition means comparing two things. I would argue that you won't be able to find a way to get to learning without some inherent comparison. What that means is that, like, if you can't compare, you can't learn. If you can't make the decision multiple times, you can't compare, and so therefore you can't learn, and then therefore you don't really have a reason to put a lot of time and effort into making the decision, because you by definition can't improve. So repeatability really matters, and if we make this more practical, you can think about the distinction between B2B sales and most B2C contexts, or high value sales versus something more transactional and low value. But B2B sales, I think, is a good example, because you have a prospect, you have one shot to send them an email, and you're probably never going to hear from them again, and you're never going to interact with them again. And so you're not communicating with them much over time for the vast majority of them. Whereas a consumer coming to your app to order food is coming back regularly, ideally, and there's lots of them. who are comparable. You kind of factor this in when you're thinking about the domain you're in, because there is different rhythms to it, which will affect your ability to apply agents or in other ways offload the decision from the human. So food delivery might be daily because people are regularly ordering. Real estate on the other end of the spectrum, you're not buying a house unless you're an investor. It's just very rare. Most people are not buying a house more than once every several years. And so you don't have the chance to repeatedly recommend them a house outside of the context of the 50 they need to see before they decide to rent or buy.
This is the failure of, I guess what you could say, call a previous generation of software for business. That, for instance, look at recommendations. There are basically two different ways you can deliver recommendations. You can send it proactively, you can stick it in a message, or it can be there on some property, a surface you own like an app or a website when people come there. If you look at the software that's designed to handle those two kinds of delivery mechanisms, they have the assumption of non-repeatability of decision-making baked into them. The core component of most messaging systems is a campaign, which is a one-off. If it's going to get repeated, it's because a person has decided to make another campaign. Like, there's nothing within the system that makes it easy to track that and track the conditions of it. To be able to track not only the decision to send, but the decision of what to send, of how to phrase it when you send it. Same thing for a website or an app. Most content management is like, okay, we're going to write our description and we're going to put up images and it's just going to be there. It's just a box you put it in. It's a store window. And yes, you can change out the store window. That's a very manual process to do that. Whereas, in fact, that's also a repeatable decision. It can be. But the most software that's been designed to deliver messages or to deliver this in-app or in-site content has been built in this very static mode, where it puts all of the burden of making something repeatable and learning from that repetition, making those comparisons like Paul said, puts it all onto the human users, which is more than is reasonable to expect from a typical human user.
Yeah, in that case, they wouldn't even know how to work with the outcomes of a decision, right? A lot of people think that, okay, now that I've made a decision, my work is done. But the real work really begins when you have some data and you need to sort of evaluate the outcome, right? Like, now that we have a good understanding of what a decision is, and the fact that we're making decisions, how do we evaluate outcomes? Is that something we can discuss?
That outcome blindness is partially, I think, the product of offloading so much of this burden onto human teams. It's not reasonable to expect that the person who's good at deciding who to send a message to is also good at writing that message and is also good at evaluating the outcome of sending those messages to multiple users. Because of limitations in our brain space, we have to divide ourselves up into teams that then have their own little division of labor. But all of that splitting up puts up walls in the decision process. Every decision now has to become multiple negotiations between human teams. And so it's no wonder that those decisions do not become repeated, because every time it's like, I finished my thing, I'm now going to throw it over the wall. I mean, I don't have to care about what that analytics team does because they're not my team.
Yeah, the outcome set and the evaluation is really important to think about together, because to the point Schaun was making, when you mischaracterize two independent decisions as two completely separate things, when really the fundamental thing that's being done is actually it's of the same set. It's just two instances of it. You've missed the opportunity to have the comparison, which allows you to have the learning. And if we kind of just take that example of real estate again, you can sort of ask yourself, well, if we're evaluating based on somebody buying it, well then yeah, you only make the decision one time because the consumer is only making the decision one time. But if instead you shift and you say what the actual decision is, the decision to say that you may think this flat is interesting. Because what you're saying is actually the person has to go through a process of making a decision about what is interesting to them over and over and over again in advance of making a decision what to buy. So you can sort of assume is actually I have a frequency of 100 because I have the chance to show them 100 apartments or buildings or houses before they buy. So it's repeatable, it's actually frequent. And then you can start to realize, well, actually I could even extend it, because if I've really thought about what I'm trying to evaluate here, because most people like to look at apartments outside of the context of buying them. Who here hasn't, gone on to a Zillow and checked the price of their house, or fantasized about living in a different house? So in a sense, you can kind of say, well, I'm going to inform all of that up to it. And you've said, oh, that's actually my decision. And I have a chance to constantly give them something that they might find interesting. And then you can kind of start to think of how would we evaluate it? How can we evaluate decision? And I think if we also just jump over and think about the context, because everyone's used to using Gen AI and thinking about how now we can apply Gen AI. And I think it's a great example. So we're all familiar with a language model. We're all familiar with a chatbot. Every time a user provides a prompt to an LLM, the LLM is really just making a decision about how to respond in the form of a sequence of tokens. Technically, that's what it's doing. So, okay, now we've seen it's making this decision all on its own. Nobody's telling the LLM what to do. It's deciding what tokens to string together. And what we know is we can evaluate it as in, is it grammatically correct? And we can say, yes, when we read it, it's grammatically correct. So we've evaluated it. But now let's think about it beyond just that very basic level of grammatically correct. If we ask the LLM, for example, to come on the nature of beauty, there's no way to evaluate that because somebody might love the definition of beauty and somebody else might hate it. And somebody else finds it irrelevant. Somebody else finds it accurate, but kind of cliche, So it's unconstrained. And so it's very difficult to evaluate it. Now, if you ask it to tell you the year Abraham Lincoln was born, there is only one single correct answer to that. And so it's possible to evaluate it. So we have factual questions and we have opinion questions. The problem is that most of our business problems are opinion problems. Most consumer businesses are not in the world of facts. So if we want to recommend something to Paul based on Schaun, we have to have some way of knowing what each of them likes. And there is no correct answer. There's no right answer that Schaun likes this house, independent of asking Schaun, does he like that house, really? Right? That's the ultimate way to do it. And in most cases, as product managers, we can't actually explicitly ask people because they'll get tired of that explicit answer. They just want you to kind of infer it and give them an idea. And then what you're going to do is evaluate their implicit response to it. When you're doing that, you realize, all right, an LLM is capable of making a decision about how to respond to a prompt, but it's actually no better at evaluating or making the decision what house to recommend to you than you or I am. Because it doesn't know, it's never asked Schaun the question of what house he wants. It can answer something, and the only way we can evaluate it is to actually go to Schaun and ask, hey, did you actually like the house it recommended?
Speaking of outcome measures, it's actually something I didn't suspect before we built AMP and we started working on these problems of trying to infer user preferences from their behavior and from experiments. But I originally thought about like the outcomes of say sending a message, presenting a recommendation, something like that, as a factual thing, like, well, they bought or they didn't buy. The problem with that is that is a very rare event. If you just want to make recommendations based on what people like, and you say, well, I know they liked it if they bought it, I'd still think that probably incorporates some assumptions, but let's say as assumptions hold true, you're going to be able to recommend very few things to very few people because most people aren't going to have that shared history to be able to, like Monica was saying, to compare these things. And so it requires you to then start looking back at other things, like Paul said, like viewing an item, just spending time looking at it is signal. Is that as strong a signal as if they purchased? What about if they added to cart? What about if they searched for certain criteria? There's all kinds of this behavior, but the more behavior you incorporate in order to have this good coverage for your measure of what did people like, the more assumptions you have to make about whether or not that's really signal or just noise. A key part, I think, of the recommender problem is figuring out what signals you have that could serve as a proxy for that outcome. Because really, like Paul said, the outcome is like, do they like it? But I mean, that's not something that in most cases we're able to measure directly. We have to infer it from behavior. Most apps we work with have anywhere between 200 and 500 different instrumented behaviors that they track on their app. All of those things mean something, but deciding what they mean is a key part of the recommendation problem that I think actually gets skipped a lot when people are implementing recommenders. They'll do some quick weighting based on some business assumptions and things like that. It's an area that I think deserves a lot more attention from data scientists and from the businesses who are informing those data scientists' work.
Yeah. So what we realize is that if we're thinking about this decision more broadly and we're thinking about, for example, our output set, our outcome set, and our evaluation process, then we can often realize that whereas many product managers might approach this as a problem of, well, the evaluation is, does the user like it? And they leave it there because they're user first and they've been taught, to always pay attention to the user. And in most business contexts, many business contexts, that actually isn't the case. Very early days in building app, a CRM team actually at a big fashion e-commerce taught me this lesson, and they said, look, every time the agents are optimizing for the user, that's fine. But you know what? The user never yells at me. But you know who yells at me? My VPs, my business vertical VPs. And they're my stakeholder just as much as the user. And at first I was like, well, wait, what? Like, don't they ultimately just care about satisfying the user? And they're like, yes and no. They care about selling their particular product. And the competition in that case can often be the other vertical. And you have a situation where the worth of every user and the worth of every item is not the same. So here you can introduce this concept of expected value. And you can sort of say, well, okay, if the value of every one of those outcomes is not uniformly distributed. So what I mean by that is like every question on a test is often worth the same. Sometimes they're not. And so you spend more time on a question that gives you more points, right? But similarly, if you're selling inventory, and let's say there's the margin. So I bought yoga gear for something, and I bought professional wear, but maybe I got a better price for professional wear. So if I sell yoga, I actually get more value as a business. So if a particular user has an 80% chance of buying yoga gear, and you're like, yay, let's sell them yoga gear because that's the most thing that they're interested in. But they have a 62% or 70% chance of buying formal wear, and formal wear is worth twice as much. In many cases, as a business, you should go for the lower probability, higher value outcome. Similarly, if we connect it back, this is why your decision set is important. Because, for example, if your goods are rivalrous, again, a real estate platform, if the real estate platform's business model is not actually renting flats, because the renting does not actually happen in the platform because it's still too much of a human process, the actual business model is giving leads to brokers. So you're just introducing somebody to the broker and it's their job to sell to them. Because the house is rivalrous, only one person can buy it. If I want to maximize my revenue, I want to make sure I make the most brokers happy because it's the brokers who are paying me. So if I give 100 customers to the first broker because he has the best house, he's only still paying me once. And I've lost any revenue from the second broker. So even if everybody loves that first house, because I know they all can't have it, for their own sake and for your business sake, you actually want to give some to the other broker. If an agent is making that decision, they have to have access to all that information. And oftentimes it's very hard to represent all that information. This kind of takes us to the information set in the form of data, in the form of some modality that the agent can comprehend or use. It's not specific to, actually, this is not like exclusive to agents. This is true of humans too. This is why when a new person, an intern or somebody joins the company, you don't allocate the decision entirely to them because they don't get to talk to the other teams. So they actually don't know that there's something more important that's going on, right? So we have all experienced that where you're like, you're upset with the intern because they made a decision that seems obvious to you, was totally not obvious to them because they weren't privy to the conversation. They weren't in the other meeting where the CEO said, this is super important. Everybody should be focused on this. They weren't in that meeting, so they couldn't know. If the agent, of all they have access to is the consumer data, all they can see is the clicks and the messages and the events, and your ERP, your business management platform is entirely separate that stores how much the value, like how much you paid for yoga gear versus professional wear, they can't incorporate that into the evaluation. And so that might be a part where the human can kind of regularly connect that data and sort of say, give you the guidance the same way you would for an intern.
Yeah. So now that we're talking about recommender systems, the systems have a particular way of discovering and then evaluating an answer or an outcome, right? So can we talk about that a little bit and maybe compare them with some alternatives?
Wait, can you reframe that?
Basically, now that we're getting back to recommender systems, and these systems have a particular way of discovering and then sort of evaluating an answer or an outcome. Can we talk about those? So basically like content-based and collaborative filtering, A/B testing, band algorithms, etc.
I tend to divide problems into two different types of decision space or action space. I'm using action space because that's what they say in reinforcement learning, and it's just habit. But you have options, like Paul was talking about. You can choose from a set of things. If that set is relatively small, then you can usually make that decision using A/B testing, or I prefer bandit algorithms because they're adaptive. If you turn a bandit algorithm on something where you have to make a decision among like 1,000 different options, it's not an approach that is well adapted for that complex a space. Whereas a recommendation system can deal with thousands, tens of thousands, even millions of different options because of the way the problem is structured, the way the technology works. And so I've seen a lot of times, because AMP's agents are kind of a super empowered version of a bandit algorithm that works differently than a traditional bandit algorithm, but the theory's similar. We usually are operating in these smaller spaces of, say, like 20 different options. You have 10 different value propositions, things like that you could explore. But when it comes to encoding what you're actually going to talk about in the message, not how you're going to frame it, but like, what am I actually going to offer to people? I've seen with several of our customers that it's difficult to cram that problem for many companies into a bandit approach. They say, well, I have like 20 different product categories. But in fact, those are only the high level categories. And there's actually like each of those have 3 to 5 subcategories. And then there's even subcategories underneath that if you're in a typical e-commerce situation. You actually have lots and lots and lots of different options, in the thousands at least. In those cases, we tend to nudge people towards looking at leveraging a recommender system. It's just a more efficient way of dealing with that kind of a decision space. Yeah, there are other considerations of like the frequency and stuff like that, but for me, the difference between those approaches really comes down to how many options are in your decision set.
And building on that, so there's how many options are in the decision set. And now we haven't really talked about the information set, but it also depends on how many things are in your information set. Machine learning, you can call it features, maybe in analysis, you call it, in science, you might call it a variable or a factor, but how many things could influence your decision within the decision set? This is really important in the way ultimately we've been building software and are moving forward towards building software. Because many data science teams make a very classic mistake of trying to solve a problem with an algorithm using an evaluation on, like, let's say a click, where you can do better and better and better, but ultimately the solution is not going to be in the algorithm. So let me kind of, we analogize, we can learn from humans. So if we take the context of movies, let's say after this call or during it, we start talking about movies and we're going to talk about what you want to watch this weekend. And you're like, hey, Paul, what should I watch this weekend, right? I got some time. I want to watch a good movie. Tell me a good movie. I can guarantee you in like out of 100 conversations between 2 people, one of them will start where the person immediately gives you a name. Unless what they're doing is really reflecting themselves and they watch that movie, so it's very top of mind and they're just like, watch this movie. If they're really thinking about you, they won't do that. And if they're really thinking about you, they won't start with a movie. Because a movie, there's too many of them. So take the movie, every movie, and then each movie has, let's say, 50 characteristics. Then you get 50 times 50,000 movies, and you get this massively large number, and it's like, you don't know where to start. So instead, what humans will do is we'll narrow down the search space. So we won't tell you the movie. We won't say, here's this movie or that movie or this movie or that movie. No. We'll say, how are you feeling? What are you interested in? Do you want to laugh or do you want to cry? And then once we've done that a couple of times, now we know you want to laugh, but you want to laugh in a sleazy way or you want to laugh in a sophisticated way. We'll narrow it down. Then I'll be like, I got the great movie for you. It's perfect. And then I'll name you one and maybe it's about right. And I'll say, well, if you don't like that, you'll like this. We're going through this process of figuring out what information is relevant for the decision of which movie out of the options. And the information helps us constrain the decision set. Now, when we're talking about agents and when we're talking about software, because that's ultimately how in almost every case we're automating the decision, we're giving it to an agent, we're doing all of that in the form of software, we have to think about the fact that the information set is not just the one we use, but it's the one the consumer uses. Because otherwise we don't have that analogous human process of narrowing down the option set. So every time a data science, so come to the mistake the data science teams make, they have access to all of the movie data. So they can figure out the year and the director and the actor and the genre and all this granular data. But now look at the actual app. And the actual app and what the actual user interacted with and saw, so we know that they saw it because they were on that screen, might be 3 pieces of it, like the title and the rating. So what they're probably doing in real life is like going to there and then they're going over to Rotten Tomatoes and they're reading a bunch of information. But it's not in your UI, so you don't get to see it. So what the data science problem is to make a latent inference. Basically, they're saying there's all this information about the movie, and if you watch the movie, in order to make the next movie, because I can't recommend the same movie, and that way it's rivalrous across instances of watching movies. You don't want to watch the same movie twice, so I can't just recommend the same movie to you. I have to figure out how to find the next movie. Is it the same actor or is it the same genre? If I didn't show that to you, it's very hard to figure it out. It's very hard to learn which piece of information you cared about because there was 50 that might have influenced your decision to watch that movie. So the information set is not equivalent across the parties, the agent and the customer or the consumer. In human relationships, it is. We share information, and that's what makes the relationship successful. When you think about a business trying to solve this problem, it's a big mistake to pay tons of expensive data scientists to try and solve this algorithmically, when actually what they need to do is solve it as well as a product and say, how can we make sure we're showing more information or the right information, not just the movie title, but the information about the movie title that allowed the person to decide to watch the movie title, because most of the time movie title is not meaningful at all. It's just whatever was chosen. Something else about the movie is why you enjoyed it. How do we show you that information in a way that the agent can observe so that they can get better at learning that it was that you cared about and not something else? And that means the decision becomes not what movie to show you, but what term to use, what way to convey the movie, what way to describe it. Because the agent can't dump a full database of information about the movie on you. No human can absorb that. They're actually making a choice, not just which movie to show, but whether to say the movie is gritty or funny or thrilling or all the things that instigate the emotion that is the reason you watch it. Because you need to feel thrill or you really want to feel emotion. We really start to realize that if we're trying to manage and improve, well, ultimately, we don't automate decisions to automate decisions. We automate decisions to improve decisions. And if we want to improve decisions, we really have to think about these pieces. We have to think about what the outcome set is, make sure we've narrowed down on the right outcome set. We have to think about the decision set. We have to think that, what is the possible outcomes here? And we have to think about what is the information that we're going to be using over and over and over to learn in order to improve the outcomes.
Yeah, fascinating. This has been great. Thank you so much.
Thank you.
Awesome. Thanks, everybody.